Okay, good morning, everyone. Let's start today's class. I hope everybody is able to hear me clearly.
Good morning, sir.
Good morning, sir.
Good morning. Can you all hear me clearly and also see
Yes,
my whiteboard clearly?
yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, great. Good. So let's start the class. So yesterday we talked about arrays, right? We saw what a character array is. We discussed the important null character, right? We discussed this null character, right? We are going to discuss this null character a little bit more later on when I teach you strings and how to handle strings. But since we are doing arrays, let's just get into a little bit of multi-dimensional array, okay? So today we'll just discuss multi-dimensional array. Okay, multi-dimensional. Now, multi-dimensional meaning having more than one dimensions. Okay, so all the basically the array that we have been discussing so far has been one-dimensional. Okay, one-dimensional meaning that you have only one dimension. This is a one-dimensional array. Okay, and in one-dimensional array, when you declare an array, you basically have a pair of square brackets. Okay, so this is basically represents a single dimensional or a one-dimensional array. Now, in addition to one-dimensional array, the C language can also support multi-dimensional array. Okay, so you can declare arrays with as many dimensions as your compiler allows, but we're not going to look at 3, 4, 5 dimensional array. We'll just look at a simple 2-dimensional array, which is also an example of multi-dimensional array. Now, 2-dimensional array is a very widely used array. Okay, 2-dimensional array is very widely used in lots of applications. You will see that 2-dimensional arrays are very useful. Okay, and it is one of the simplest form of the multi-dimensional array. So let's focus on the 2-dimensional array today. Okay, now whatever you learn, while we are discussing this 2-dimensional array, that can be extended to more than 2 dimensions. However, we will focus on 2-dimensional array. So how do you declare a 2-dimensional array? So let's try and declare an integer array with 2 dimensions. All right, so this is how you declare an integer array with 1 dimension. All right, but if I have to declare a 2-dimensional array, I will be declaring it something like that. So I'm declaring an integer array. So here is my ARR. Okay, let that be a 2-dimensional array. And here I have to give both the dimensions. So here is my 2-dimensional array. So I say 2 and 3. Now, what exactly does this mean? Right? It means that this is a 2-dimensional array with size 2 and 3 integer elements. What it means, the structure will not be like this, but the structure will be something like this. Okay, this is going to be the structure of this array. What does 2 signify? So you can kind of correlate this 2 with rows, right? This row, you can correlate this with rows. So this is row 1 and row 2, and you can correlate this 3 with columns. Okay, so you can correlate this with C1, C2, and C3. All right, so this is going to be the first row, which is represented by this. So the first dimension represents the row, and the second dimension represents the column. So this is how the structure of this particular array would look like. Okay, now how can you initialize basically the 2-dimensional array? Now, how do you add the values here? So which numbers here will represent which values here? For example, when we have this, when we talk about A0, we know that A0 represents this memory location. When I talk about A2, we know that A2 represents this one. So how is this memory location, accessed? So let's take an example. So suppose I write ARR, I'm initializing some values here. So how do I initialize? How do I reach, across these memory locations? So if I write 0, 0, if this position will signify this particular memory location. So if I write, let me just write a number here, is equal to 1, my 1 is going to get placed here. Similarly, if I write 0, 1, right? So the first this what you call the element that I have written here is 0, 0. That means this is representing a row, right? So in the first row, the array always starts with 0. So in this first row, which is represented by 0, the first element is 1. The second element is represented by this 1. So if I write 2 here, the 2 will go here. Similarly, 0, and if I write 2 here, this 3 will come here. Are you able to understand this? So the first dimension represents the row. We are working on the first row itself. Okay, 0, 0, 0. The starting of an array is always with index 0. So 0 represents the first row. So in the first row, I am, I have 3 different values here. That means the column values are changing. So this is my first column, this is my second column, and my third column. So first column, second column, third column. In the first row, I assign these values. So 1, 2, 3 will go here. Similarly, if I have to assign values here, I have to access this array using, now I'm accessing the second row, which is the index 1. And in this second row, I will be accessing the first column, so which is 0. Now here I can write 4, and similarly, I can write 1, 1, and ARR 1, 2. So you can write 5 and 6. So the 4 value will come here, 5 will come here, and 6 will come here. So did you understand how these memory locations are accessed and how the values are initialized?
Yes, sir.
Yes, okay, quite simple. Now, one important thing that you can see here is that when I'm actually working with initializing values, or even if I want to read the values in a sequence, then a very important pattern develops. The pattern develops is to access the first 3 numbers here, that means 1, 2, 3, I have to keep the first dimension same. That means this represents the row. So the row value, which is the first dimension, needs to be same. So 0, 0, 0. What is changing is my column value. So 0, 1, 2. Right? So my row value remains the same, column value changes. Again, when I go to the second row, my row value changes, that is 1, 1, 1. And my column value is again being, it's changing, 0, 1, 2. So if you look at this, in the previous example, when we handle one dimension array, we use for loop, right? We use for loop. So we use for loop, and using this for loop, I run the loop 4 times and I can access these values from the array. But in this case, in the second dimension array, 2-dimensional array, I need how many for loops? I need 2 for loops. One for loop to operate this row, and the second for loop to operate this column. Okay, so when I work with 2-dimensional arrays, I have to use 2 for loops. And also when I'm using 2 for loops, they have to be nested. That means one for loop will be under another for loop. So which one is to be nested inside which one? So if you look at it, first we start with the row, right? So we use one for loop, which is going to iterate how many times? 2 times. So it has to, because the numbers here are 0 and 1. So I will have a for loop here, which will run 2 times. And inside this, I have another for loop, which is going to run 3 times here, 0, 1, 2. So I need to have another for loop inside this, for loop, which is going to iterate 3 times. Okay, so what happens in the first for loop, when the value of say I is 0, right? Inside that, I do 3 number of iterations. So 3 number of iterations to access the 0, 1, and 2. So these 3. Again, in the second iteration of the first for loop, when the value is 1, I will again do 3 iterations of the second for loop. So what exactly happens is, it's something like this. So you have one for loop, right? So you have one for loop here, okay, which will have its first iteration. Inside this, there will be 3 iterations for the column. This is for the row. And again, in the second iteration of this for loop, which is for the second row, you will have again column. So your structure that you have, the 2-dimensional array, sorry, this is not the right one. I had 2 comma 3, right? So the structure which I have was something like this, 2 comma 3. So 2 rows and 3 columns. So my iteration should be this way. So first for loop will actually point here, and then the 3, 1, 2, 3 values will be read. Again, the second for loop, this will point here, and then I will be reading these 3 values. Okay. So whenever I use a two-dimensional array, please remember that in order to access the elements, I have to use 2 for loops. So let me just give you a small example so that you can understand it better. So let's write a main method, right? And I'm going to declare a two-dimensional array here. So let's say two-dimension array. So let me write dim, okay? And let me declare the dimensions. So I want 3 and 5. What it means that I have basically 3 rows and 5 columns. Okay, so my structure is going to be something like this: 3 rows and 5 columns. So here is my row 1, 2, 3, 1, 2, 3, 4, 5. This is the structure of this array. So let me initialize some values here. So when I'm initializing the values, let me initialize it because it's an integer array. I can initialize it. So let me write it in the same format. So let me write it in the same format so it's easy for you to understand. So 1, 2, 3, 4, 5. Okay, put a comma here. Then I'll write it down: 10, say 20, 30, 40, and 50. And then I can write 100, comma, 200, 300, 400, and 500. So these are my values, and I close this. So when I declare a two-dimensional array, all these numbers will be placed here. Okay, this is one way of declaring all or initializing the values in a two-dimensional array. So when I write it, what happens is it will start putting values from here. So 1, 2, 3, 4, 5. So the first row will get completed, and then the second row will start. So the values will start from here: 10, 20, 30, 40, 50, and then 100, 200, 300, 400, 500. So this is the way by which these values are going to get initialized into this array. So far so good. Now let's try to retrieve these values and print it. So when I want to, the whole point in me showing this problem is to show you how 2 loops are required in order to, read or write to a two-dimensional array. So if we are going to use 2 for loops, let us declare 2 integers which is going to run the loop, I and j. Now first we have to basically run this loop. So this is going to be my topmost loop, and this is going to be nested inside that, right? So let's write my first for loop. So my first for loop is going to start at 0, right? And it is going to run till 3 because my row has a dimension of 3, right? And I do I plus plus. So this is my first for loop. Okay, so what I'm going to do is I put this here. Right, now what I'm going to do is I can also write another statement here, but let me just put a print. I'm just going to do I'm going to print a line so that it goes to the next line. Now inside this for loop, right, and inside this for loop, now I need to have another loop, and that will be for this, that is my column or the second dimension. So my second dimension, I will use this j here. So now I'm writing the for here so that you know that this for is inside this. Okay, so I start j is equal to 0, and here my j value will be less than 5 because I'm going to run the second loop here. All right, and then I do j plus plus, and now I can print. Now, if I want to print this in this format, what do I have to do? If I want to print the values in a nice format, then I need to format, right? So I'm going to put %60. You know what this is going to do, right? Do you remember what this is going to do? Anybody remembers this? Anybody remembers why I have put this percentage D here? What is this D going to do? Nobody remembers?
So this is going to leave those places and shifted the number to the right.
Yeah, what it does is it will actually, for this one, it will leave 6 places.
Yes, sir.
Okay, so why do we do this? So that our format comes better. So when I print it out, I will get, because there is 3 numbers here, I've used another 3 numbers, so there'll be nice spacing and my output is going to look neat. That's the reason I have put this percentage 6D. I can put 5D, 4D also, but I've given it extra space so that it spaces out really well. Okay, and here I'm going to do I comma j. Okay, and I close this loop, and I will write another printf so that it prints in the next line. Okay, and /n, and I'm writing return here. Okay, I'm writing return 0 and closing this program. So what's going to happen now? The for loop is going to run with I value 0, right? It's going to come print 1 line. So it's going to leave 1 line and then go to the next line. Here, the j value will be 0. So in the first iteration, the I value is 1, j value is 0. And it is going to print, right? What? I0, j1. So it's going to print 0, 1, this memory location value. So which is this memory location value? So this starts with 0, 1, 2, and this is, right? Sorry, j value will also be 0 in the first iteration. So it's going to be 0, 0. So it starts with 0, 1, 2, 3, 4. So this 1 will get printed, right? Now, once 1 gets printed, this loop is going to run again. Okay, so you will have 1 printed. Then this loop will again run because it will check whether j value is less than 5. Yes, the j value is less than 5, right? So next j value will become 1. So I value still remains as 0, but the j value becomes 1. So 0, 1 is this value. So 2 will get printed. Now, whenever I'm printing 1 and 2, they're going to get printed in the same line, but with a spacing of 6. Okay, so 6 will be the space. So this will be 6, another 6 here. So 2 will get printed here. Similarly, 3 will get printed here. Similarly, 4 and 5 will get printed here. After 5 is printed, it will come here with j value 5. It will check that yes, j value is less than 5. No, it is not. So it will exit this loop. Okay, so it will exit this loop, but it will go to the next iteration of the for loop here. So what will be the next iteration of the for loop here? The next iteration of the for loop here is going to be what you call this one or this one, where the I value is going to be 1. So when the I value is 1, it will print this entire row just like it printed here. So you're going to get it nicely printed in this format: 200, 300, sorry, 10, 20. This is going to be 20. This is going to be 30. So you're going to have something 30, 40, 50. Similarly, it will go again to the third iteration, and in the third iteration, the I value will be 3, and again you will have 100, 200, 300, 400, 500 printed in a nice sequence. Okay, so the example which I just discussed right now is for a 2-dimensional array. Now you can take this concept of 2-dimensional array and perform lots of operations. Okay, I'm going to give you some assignments in a day or two. I'll ask you to write some programs, okay, related to this array. If you know matrix, if you know operations on matrix, if you know matrix addition, subtraction, division, multiplication, all of that, a 2-dimensional matrix can be easily performed using this concept of 2D arrays. Okay, so I will give you some assignments that you have to actually solve it, and then we can discuss those assignments in the class also. Now, important thing is that you've seen all this while that we are giving these dimensions. We are giving these dimensions from before. Okay, during the declaration of an array, we have to give the dimensions, or we have been giving the dimensions so far, right? Which means that once before you actually declare an array, you have to count all the elements that you're going to have in an array. And then after that, you have to find the size, and then you have to specify what is going to be my, the dimension that I need to specify. So for example, if I want to, declare an array, say with 10, this dimension, right? Before I declare this 10, I need to count, I need to figure out how many values are going to be there in that array. Now, can I, can I do something where I don't declare the dimension at all and let the compiler calculate the dimension depending on whatever is the size of the values which are being initialized there? Okay, so the good news is that C compiler can actually do that. It can actually calculate the dimension or the size of an array automatically if the array is declared as an unsized array. So you have something called as unsized array, and in an unsized array you don't have to give this value. Okay, the compiler will automatically calculate this and it will allot the memory location based on the number of values that we have initialized. So for example, I can write something like this, int a, and I don't specify anything, which means that this is an unsized array. Okay, and then I can put any values I want. If I put these 3 values, the compiler will allocate 3 memory locations for this. If I initialize more than 3 values, that means I can write 40, 50, the compiler will automatically initialize 5 memory locations for this. Okay, so the compiler will create an array which is big enough to store all the elements that you have initialized, right? So this type of array where you don't define the size, such arrays are called as unsized array. Now we can create unsized array in 2 dimensions also. Okay, but it's important that when you're creating an array in 2 dimension, okay, you can specify the first dimension as an unsized array, but the remaining ones you have to give the number. You can't do something like this. This is not allowed. The first one can be unsized. That means you can specify, that this is an unsized. So the row has to be specified all the time. After that, the row can be unsized, but all the other dimensions, that means column values, you have to give. Okay, that's a rule, because it's difficult to figure out, what is going to be, how the structure is going to be here. But if I know that, okay, I have 2 columns, but number of rows I may be variable, that's fine, because whenever you're creating a table or whenever you're creating a data, you always define the attribute of the data. For example, age, right? Age and roll number. So you have to define this, right? You have to define this age and roll number, but the number of data that can fit in here can be variable. That means I can put 100, 200, I can have 30 rows, I can have 100 rows, I can have 200 rows, and that's fine. But these 2 has to be defined. If I have a scenario where I don't define this and I don't define this, then it is going to be difficult to structure it. You can't structure it. So in a 2-dimensional array, you can keep the first dimension, that is the row, as unsized, but your column need to be defined. Is that clear? Did you understand this?
Excuse me, sir.
Yeah.
Sir, is it possible we can give the information about row and we just wanted to be unsized to column data?
No. You have to, if you want to unsize it, so basically what you're talking about is, removing the age and roll number and giving, basically the number of rows, but the columns, you don't know what value they're going to come. That you cannot do. You have to specify the header, and the number of data that can go inside those headers can be variable. Are you getting it?
Yes, sir.
So you have to specify, the dimensions of the column. That means you have to specify the second dimension size. The first dimension size, you can skip. That means you can, this can be unsized. All right, so I'll give you some small questions probably by the end of this week, so that you can practice a little bit on arrays, because array is an important concept and you need to practice some programs. The unfortunate thing is that many of you don't have your computers, don't have your laptops, so I don't know how you're doing your labs. but you need to practice these. So I mean, is there anyone, how many of you are there in the class right now who don't have laptops? I mean, can I have a small count? Can you just write in the chat box, I don't, in the chat box, please? Those students who don't have laptops. So everybody's got a laptop? I think there are a lot
Yes,
of
sir.
international students who don't have laptops, okay? Yeah, that's good. So I think most of the international students don't have laptops, but all the students, Indian students, you have laptops with you right now?
Yes,
Yes,
sir.
sir.
We got
Yes, sir.
Okay. Okay,
that
good,
all.
good. Oh, then that's fine. Then I can give you programs. So I'll give you some programs to do. So for you to practice, and you can try and execute those programs. And then if you're not able to do it, then probably we can get together and do it. Or if no one can do it, then I will do it. Okay. So all the others who don't have a laptop, so we'll see what we can do. I can try and get you one. It's very difficult to write programs without a laptop. So we'll see. Anyway, you just learn whatever is being taught. When you actually get hold of your laptops, then you can practice it later. Okay. So we will talk a little bit about strings. Okay, we still have some time to go for today's class. So we will talk about strings. So previously we learned how to use arrays to collect variables of the same type, right? We also learned that a character string is actually a character array with a null character. Okay, it's important. It's important because if you have a character, can you all hear me clearly? Just confirming.
Yes, sir.
Yes,
Completely
sir.
clear.
Okay, okay,
Yes,
okay.
completely
So if
clear.
Yes,
I
sir.
create an array and this array I have only characters in it, okay, then this is called as a character array. This is called as a character array. All right, but if you have the same thing, a character array, but you have a null character at the end of it, okay, if you have a null character at the end of it, then this is called as a character string. Okay, just remember that. I told you yesterday that you can do operations on this also and you can do operations on this also. But when you are declaring only a character array, that means you will not have a null character at the end. I briefly told you yesterday also about this. But if you have this null character at the end, then this is called as a character string. Okay, so there is a small difference having null and not having null. If you don't have null, it's a simple character array. You just take, like you have a character, you have integer array, you are defining a character array. But strings come into the picture when you have this null character. Okay, so null character is important in C because it marks the end of a string, and also it defines what kind of this array is. What kind of array it is? Is it a character array or is it a string? Should I look at it as a string or should I look at it as a character array? Now that's why this null character is important in C. Okay, so we're going to talk about how to declare and initialize strings, because strings are a very important part of your programming, right? Also, we'll look at what is string constant and what are character constants. So let's look at strings once again. Now, what is a string? A string is a character array with a null character, right? I just told you that. What is null character? Null character is basically a very special symbol which is used to mark the end of a string, right? And as I told you, that how you will define yesterday's class, how do you define a character string? So you can have something like this, right? And you can initialize some values into this. And yesterday we initialized hello, so we will do the same today. So there is a single quote. It's not a double quotation because double quotation has a meaning, which we will discuss again. So we have HELLO, and important thing, here is my exclamation mark, and I have this null character at the end of it. So this is it, right? So now, because I have a null character at the end of this character array, now this is a character string. Okay, now you can have series of, now if you have something like this, Okay, what is this? These are series of characters, but they are enclosed within double quotes. Okay, you have series of character HELLO. We don't have to separate it using commas, but these are a series of characters which are enclosed within double quotes. Now this is called as a string constant. Okay, this is called as a string constant. Okay, if you are declaring a string constant, remember this is an important point. If you are declaring a string constant, the C compiler will automatically add a null character at the end of it. Okay, to indicate that this is a string. Right? So a string character is considered as a string constant. So if I write hello here, this is a string constant. Automatically the compiler will place this null character at the end of it. Okay, so how do you initialize a string? So I told you here, if you actually have this null character at the end of the character array, then we define this as we categorize this as a string. However, there is another way to do it. I can straight away write character str, suppose 7, and here I'm initializing a string. Look at this, right? HELLO. So I'm going to write HELLO and I'm going to close it. Now here is a double quotes. Let me just do it in a new screen so it's clear. So I can do this. So I can declare a string something in this way. This is the one way of declaring a string is, sorry, let me just write it. HEL. Okay, let me stop at hell. Let's forget the hello. Let's make it small. So 1, 2, 3, 4, 5. So the 7 becomes 5. So this is one way of declaring a string, initializing a string. Okay, this is one way of initializing a string. Another way is by simply writing that's it, hell. Okay, now this is a simpler way of initializing a string. Now, what is the difference between this and a character array? Now, in this case, the compiler will automatically add this null. It will automatically add this null character at the end of this. So you don't have to worry about this. So if you're declaring a string using character array in the same way as character, your character arrays, or for example, not the string, the character arrays are defined, then you have to, initialize it one by one, and then you have to add this null character at the end. But if you're just going to simply work on strings, then this is the easier way of initializing a string. All right. Now, another way of using unsized character array, like for example, here you have to count the number of characters which are there in the string, and then you have to write this 5, because HELL means 4 characters, then that null character also has to be there. So I am initializing this character of size 5. But you can also simply write character ARR, right? Write it as an unsized array, and you can write anything that you want here. This is a string. Did you understand this? Now this is very important. Did you all understand this?
Yes, sir.
Okay, so you can use an unsized array to initialize a string. So when we work with strings, we don't work by initializing the string in this format. Okay, because we have to do a lot of operations on strings. When we work with strings, there are lots and lots of functionality of strings. That means strings are a very important integral part of your programming, because if you look at our life around us, we have data in the form of a string. What we do, we try to do a lot of things with strings. we try to concatenate the strings, we add the strings, you can extract some information from the string, we write lots of text messages which are formed in sentences, and if you look at the sentences and paragraphs and everything, they are all made up of like strings. They are, you know, those characters which are combined together. So it becomes very tedious if we have to declare a string in the form of a character array. Okay, it becomes very tedious. So imagine, you know, declaring a string using this. It's very, very tedious. Rather than that, when we work with strings, this is the way by which we actually initialize a string. So in the next class, what we're going to do is we're going to talk about some of the operations that we do on strings. Okay, so once we know how to initialize a string, then there are different ways of modifying or operating or finding out the length. So suppose you have a huge long string and you need to find out, you know, how many bytes is actually utilized in the memory, how many bytes is allocated for that string. Right. So if you look at a string, each of these string elements contain of one character. So you actually have to calculate one by one, you have to count. So rather than doing that, you have some functions like string length, which will easily find out the length of your string. You have functions like string copy. So you can take two different strings and you can combine them together, or you can even copy one string to another string. So all these operations can be done easily in C. So we will be looking at some of the string operations tomorrow. Okay, and also since you guys have been doing a lot of inputting the data by the user, you've been using scanf function. So tomorrow I'll also introduce the scanf function because I see that you've already been doing it. So tomorrow I will introduce some string operations, some functions using some string operation functions, and I will also introduce your scanf, and I will also try and give you some programs so that you can practice related to this, and then we will move on to the storage classes. Okay, so we can stop today's class here. If you have not given your attendance, you can please give your attendance right now. Only those people who are giving attendance on the chat box, I'm going to update their attendance, okay? Others, please do not tell me that, sir, I forgot to write and all that. Just do it right now. You have enough time to give your attendance. Please ensure that you write, you give your roll number in this. And even if I forget or your attendance is missing for a day or two, don't worry about it. Because normally what happens is, I'll tell you about this attendance thing, okay? For me, this attendance is used to evaluate whether you will be able to write your exams or not. If you have low attendance in the class, then you are debarred from writing the exams. But this year, this semester, since it is online and since people are still joining in, people are joining in late, some of the students are joining in, now, so this attendance thing will not be considered for you to write your exams. You've already written your mid-semester, right? Everybody's got a chance to write your mid-semester exam. So you don't need to worry about attendance but when you come to college and when you start attending physical classes, that time you need to have a minimum of 75% attendance in order to appear for your exams. But all of you got a chance to appear from mid-semester. So we don't have a debarred list this semester. So even if we miss out on 1 or 2 attendance, don't worry about it at all. Okay, so you don't really need to focus on getting 100%, 90%, nothing. It doesn't matter. But when you come to the college and physically you're attending the class, that's the time you need to be very careful about your attendance. For now, there is no problem. So if I know most of you have been attending, if you don't, if I miss out or you miss out, doesn't really matter. Because you've already been allowed to sit for mid-semester, you will be allowed to sit for end semester also. So no problem with attendance. Okay, I don't give any marks for attendance as well.
Okay. Excuse me, sir.
Okay, yeah.
Sir, as you said that in string part, one will enter a words. So at the end of the string, automatically /0 will gonna be add. So
yes. In this case, in this case.
So if suppose, sir, I'm declaring a size of a string like 5 and entering hello, so how the /0 will gonna be add?
There will be a problem there. You try. They will say that there is, you'll have the compiler will tell you that you have declared, you're trying to enter more values into a string which is of a smaller size.
Okay, sir.
Okay,
Understand.
so that's why, because there is a problem there, because you can't count, and because if I have a very long string, for example, a paragraph or something, a huge string, so in order to declare an array to store that string, I need to. It's very tedious for me to count one characters and then find out the total. Most of the people, what they do is randomly they will give some thousand, but that's also not right, because if you have a string of size 500, and if you declare an array of 1000 size, then what's going to happen is your 500 is going to get wasted, that memory location is getting wasted. It's something like you buy a 2 terabyte of hard drive, but you are using only 1 terabyte. So you should have bought a hard drive of 1 terabyte, because your 1 terabyte is always empty. So why did you pay that extra amount to buy the 2 terabyte hard drive when you're not using it all? So same concept is here. So that's why this unsized array becomes important. So you don't have to worry about the size. You just declare, initialize your string. The compiler will automatically calculate what size this array needs to be, and it will store it.
Sir, another question, sir. Is there any specified data type is used for unsized array, or we just leave the square bracket as it is, and the
Yes,
compiler will gonna be count?
you just leave the square bracket without writing anything here. That's all.
Okay, sir. Thank you, sir.
Okay. All right. Fine. So please give your attendance.